Okay, class, welcome again to our next session. We're continuing with triangles. The last session, we learned that triangles are flat figures with three sides. We learned that triangles are, when you add up all of the angles, it comes always to 180 degrees. We learned that if you have, say, one angle is 30 and it's a right triangle, well, that's 90 plus 30, 120 together. Subtract that from 180, and you get a 60-degree angle left. So we're going to continue on, okay? All right, different types of triangles. I want you to pause the recording, copy everything on the screen, and we'll continue in 5 seconds. All right, so we're going to have a couple of there's like 4 different types of triangles here. So each one has its kind of own unique properties. So we're going to jump into it here. First one's called an equilateral triangle, and it's got the word equal in it, and that's kind of a hint. If I circle the word equal in it, everything about it is equal, and that's why they call it an equilateral, okay? So, for instance, it has 3 sides that are equal, or it has 3 angles, excuse me, that are equal, okay? So in this triangle on the right here, this angle here is equal to this angle here, which is equal to this angle here, okay? And by the way, just doing a little bit of math here, if it's an equilateral triangle and all 3 of them have to add up to 180, well, let's just ask you this question. How many times does 3 go into 18? 3 times 6 is 18. So each one of these is 60 degrees, okay? So in an equilateral triangle like this, okay? So that's why it says each angle measures 60 degrees and all the sides are equal. So everything is equal. Sides, okay? This side here is equal to this side here, which is equal to this side here, all the angles, all right? All right, here's an example question you might run into in your homework and on your unit test. What's the measure of each angle in the triangle to the right? Okay, well, we kind of already did that already in our math. We took 180 and divided it by 3, and we got 60. Okay, so if you just divide it by 3, that gave us a total. Okay, all right, I'm going to move to the next slide. All right, we have another type of triangle. So go ahead and pause the recording, take your time, copy all this down, then press play. All right, isosceles triangles. So this is another one. So we had equilateral triangles where everything was equal, okay? Isosceles triangles has just 2 equal angles, and the sides opposite the equal angles are equal, okay? So let me just show you over here to the right what that means, okay? What it means is that these 2 base angles at the bottom of this triangle, angle X and angle Z, they're the 2 that are equal, not 3, but 2. And it says that the angles that are the opposite, the sides that are equal. So this is the opposite side here. So this side Y, I could say side Y, Z, okay, that is the opposite. So that means, and then the opposite angle Z, this side YX, okay, so you got YX here. That side is equal. Those 2 sides are equal, okay, because they're the opposite of the equal angles at the bottom. All right, so kind of just in summary, what's the difference between an isosceles and an equilateral? And in an isosceles triangle, only 2 angles are equal and 2 sides are equal, okay? So that's the difference, all right? Here's an example problem in the bottom left of your screen. What's the value of the base angle in the isosceles triangle at the right? So they've introduced this term base angle. So I'm going to come over here to my diagram here and kind of show you what that means. In a triangle like this, the top angle here, angle Y at the top, is it's called the vertex angle. It's kind of like the top one. And the 2 equal angles at the bottom, angle X and Z, they're the base angles, okay? So you get the vertex at the top, at the very vertex of it, like the peak, and then you got your 2 base angles. So in our problem, what's the value of the base angles in the isosceles triangle on the right? Step 1, subtract 50 from 180, you get 130. All right, so let's look at the triangle here. Okay. So they only gave us, let's pause here for a moment here. They only gave us 50 degrees, and they want to know what angle X and angle Z are at the bottom. Okay. So, well, let's start doing the math we can do, right? We're only given one thing, and we know the total is 180. So back here at step one is we're going to subtract 50 from 180, and that will give us, there's 130 degrees left. Okay. Now, if you think about it logically, if there's 130 degrees left, and these angle X and angle Z at the bottom right here of our screen are equal, that means if I divide 130 by 2, since they are equal, that gives me 65 degrees. Okay. Hope I didn't go too fast on that, but that gives me 65 degrees. So again, what we did was they want to know what X and Z are, those angles. We know they gave us 50. We subtract that from 180, that gave us 130. We know there's two angles left and they're both equal. So if we divide 130 by 2, that tells us what those two equal angles are on the screen. Okay. All right, moving on to my next slide. All right, another type of triangle. Oh, I'm sorry, we're still working with isosceles. Okay, continued here. So here's another type of problem you might have. What is the measure of angle S in and angle R in the isosceles triangle to the right? Okay, so angle S is this one here. Okay, they want to know this one here, and they want to know angle R. Okay, trying to figure out those two. What have they given us? They've given us 70. So the very first step we want to do is we want to subtract 70 from 180. Okay. Let's see here. However, they want to know what S is. Well, if this is, it says to us, this is an isosceles triangle, right? By definition, folks, they want to know S and R. By definition, if it's isosceles and they gave us 70, those two base angles are equal. So that means right off the bat, we can just figure that S is 70 also because they're equal. Okay. Now, step 2 here. To find R, subtract the sum, which means sum means adding, of the base angles from 180. So 70 plus 70 is 140. So if I add these two together, these two angles at the bottom together, excuse me, I'm going to get 140 degrees. And if I subtract that from 180, that gives me 40. And that's what R is. R is 40 degrees. Okay. So that's how I would do that math. Okay, we're on to our next slide here. Go ahead and pause the recording, copy down what you see on the screen as best you can, and we'll talk about it. Okay. All right. So what we have here is we've got scalene triangles, another type of triangles. So we talked about equilateral. That means they're all equal sides and angles. We talked about isosceles triangles, where two angles are the same and the opposite sides are the same. And now we've got scalene. Okay. And in a scalene triangle, it has no equal sides and it has no equal angles. Okay. So in my yellow triangle over here, angle B, A, and C are all different. And you look at the side lengths, they're all different. So, and by the way, just in case you wondered, most triangles are scalene. They're not a right, or they're not isosceles, or they're not equilateral. Now, I've got a little note in the bottom left-hand corner here, and that is if you're trying to find a missing angle, trying to find a missing angle in a scalene triangle, subtract the two that known angles from 180. Okay, so the two known angles from 180 is what you would subtract. So looking over here to the right at this triangle here. I can see that I'm given 70 and 50, and I can add them together, and that gives me 120. Okay, if I did that in my head correctly. And if I subtract that from 180, I could just do that math right here, and that's 60 left. Okay, so 60. And so that means that angle A in this triangle would be 60. Okay, all right, moving forward. All right. You also will see sometimes, I just want to be sure and point this out because you'll see in your homework, they'll just give you a right triangle and they won't say a whole lot about it. But there are there are things called isosceles right triangles. And I know right now you're going, hey, teacher, I'm feeling a little bit overwhelmed. Um, Isosceles just means, as we mentioned before, it has two equal angles, right? And then it's a right triangle. So in my example over here to the right here, this has, you can see that little box there at the bottom there. That means that's a right triangle, and it's the two other angles are equal. So it's isosceles, okay? Because all three angles are not equal, but it's a right triangle, so the other one's 90 degrees, okay? And then you also can have scalene right triangles. Remember, we just learned scalene means none of the angles are the same, okay? None of the sides are the same, but one of them happens to be a 90-degree angle, okay? And so I just wanted to reinforce that because in your homework and possibly on your unit test, it might just give you a triangle like I'm pointing at here, and not even say 90 degrees, but you have to look at that and go, oh, that's a right triangle. I know in my head that's 90 degrees. And so that'll help you solve for that. Okay. Now we're going to move on to an example problem that I just mentioned. Okay. What's the value of the base angle in the isosceles right triangle BCD? All right. All right. So it's asking for what's the base angle in the isosceles right triangle. So which angle is that? Okay, so I'm going to change the color of my pen here so it'll actually show up a little bit better here. Um, so we know that it's an isosceles right triangle. So we know this one here is 90, okay? We know that already, that this one's 90. And because it's an isosceles, this is where those definitions come in really handy. Because it's an isosceles here, isosceles means two equal angles, right? And two equal sides. In fact, by the way, you see these little dashes here I'm circling here? If you see these on an geometry problem, see how there's just one little dash there? That means that that side is equal to the other side, okay? It has the same one dash. If there were two dashes up at the top and two at the bottom, it just means those two sides are equal. Okay, they have the same length. All right, here's how we'd solve it. Step one is 180 degrees minus 90 degrees gives us 90 degrees left, okay? That gives us what's left is 90 degrees. Now, if I divide 90 by 2, I get 45 degrees. Why did I divide 90 by 2? Because I have two angles here. I've got angle D and I've got angle C left. And if I divide by 2, I've got 45 degrees. So that is how you would solve that problem. And so if you run into them when they don't actually tell you that but there's this little box here that I'm pointing at here, just know that's 90 degrees. And pay attention to the type of triangle it says. If it says it's isosceles, that means the other two have to be equal. If it says equilateral, that means they're all going to be 60. Okay. And if it's a right isosceles or a right scalene, it means one of them's 90, and that's our starting point. Okay. All right. At the end of this video, it says here, I want you to complete all the problems on pages 50 through 51 in your textbook. And be sure and send me an email if you run into any big problems. And good luck.